Yo, Jerome.
Yo, what's up?
Why did the C++ program run in the toilet?
Why?
Because he was trying to CPP.
Yo, what's good? It's your boy Premier. Types, objects, values, variables.
Let's do it.
Alright, cool. So let me ask you something, yeah? What is a program that has no data? Well, it's nothing. Okay, cool. Well, going back to what I said last video, yeah? Turn right outside my house, walk about 10 yards, and turn right again. The computer's gonna have to have a mad detailed breakdown of what walking is, what turning right is, what a yard is, and what 10 of them are. So to define all of this madness, yeah, we need to have data. Otherwise you'll have nothing, because the PC will be like,
Bro, what the fuck? What you on about?
okay, so a little disclaimer, yeah? This episode is gonna be a little more theory than the other one. So yeah, sorry not sorry, innit? Anyways, let's start with types. You see, a type here represents the kind of information that you wanna store. Alright, for example, yeah, let's take the number 1 and the letter P. In human languages, yeah, we can understand that a number and a letter are two completely different entities, right? Well, so does a computer. It understands that these two objects are of two completely different types. With each type, yeah, a computer defines a set of possible values and a set of operation for these objects. Like, for example, you can multiply two numbers, right? But multiplying two letters, what? In addition to this, yeah, a type tells a compiler how much memory it has to set aside for a variable of this type. Alright, look. Like this massive number, yeah, and this little letter don't take up the same amount of memory. It'd be pretty stupid if it did, to be honest. Okay, cool. So there's some fundamental types that are built into the language of C++. And in the next section, I'm gonna go over each of them and what they do, how they work, all that stuff in mad detail. But these types are Boolean, characters, integers, floats, and doubles. Alright, cool. Next are objects. Remember how a type tells a compiler how much memory to set aside for a variable of the type? Well, an object here is simply some memory that holds a value of this type. Like, okay, think of it as a box, yeah? We have a box and we put values in it of a given type. An int box can hold integers. A char box can hold characters. An idiot box can hold idiots. Okay, well, there's no type called idiot. Anyways, yeah, so just think of an object as a box with some values that are put in it. Alright, plus. Next is values. These are pretty simple, to be honest. Remember how an object is just a box? Well, this box will be empty unless you put a value in it. Values are simply pieces of data that abide by the rules of the type. Like, let's take characters for instance, yeah? P is a character value. H is a character value. But Terrell, yeah, is not a character value. It is a collection of characters which now need to be represented using a completely different type. Okay, so lastly, variables. Well, these, yeah, are simply named objects. Remember when I said earlier that you can't do anything interesting with a computer without storing data in memory? Well, to access that data, we need to put it in an object. And to manipulate that object, we need to give it a name. And that is basically what a variable is. And it's called a variable because the data within it can vary. Alright, sound. So before we continue, I'm gonna go over how all these things are interlinked. A variable has a specific type, which determines what can be put into an object and what operations can be applied. And the data that we put into these variables are called values. Alright, finally, man. Theory is done. Now it's time to get it down. Alright, so boom. First, create a new project and create a new source file called main. Once that is done, just set up a basic program like we discussed last episode. If you're a little unsure, yeah, just copy this code. The breakdown of this code is in a previous episode. So the first type we're going to discuss is Boolean. This is a simple type that can hold a true or a false value. Simple as that, really. You see, this statement right here is called a declaration. Basically, you're just requesting a variable to be created. You see, when you want to create a variable, you need to do at least two things. Tell the compiler what type you want to create, here is Boolean, and tell the compiler what name you want to call this variable. Here I just called it Boolean. Okay, so a little disclaimer as well. Compilers are mad anal about the naming of your variables. Your name can only contain letters, numbers and underscores. It can't start with a number, yeah? And it can't be a C++ keyword. Don't worry about it, the keywords I'll go over in future videos. Okay, so the next type is characters. Chars take single character values and there's up to 256 different character values that it can take. You cannot put a collection of characters into a char, only one single character. Okay, so integers. These are just whole numbers. Integers can take numbers in this range as long as they're whole numbers. Floating point numbers. These are basically decimal point numbers. Here's the range of the values that they can accept. And lastly, doubles. These are the same as floating point numbers, but they're just more precise. Computers can't accurately represent floating point numbers, so there's an option to take up more memory with a double, but you gain much more accuracy with it. Okay, chillin', that's all the types that are built into the C++ language. Not many, but trust me, you can do a lot of mad things with these types. Okay, so there's no point in declaring variables and not giving them any values. So this is what assignment is for, giving a variable a value. The equal sign is called an assignment operator. So to assign a value to a variable, you type the variable name, then the assignment operator, and then the value that you want to assign to that variable, followed by the semicolon to end the statement. You want to assign variables that are made for the type. Otherwise, the computer will think it's smart and try to convert that value to fit that type. On rare occasions, yeah, these automatic conversions can be useful, but more often than not, they're just mad annoying. So here are some examples of me assigning values to some variables. So I may be assigning lots of values to these variables, right? But the way a computer works, it runs sequentially, meaning in order. So when it gets to the next assignment statement for that variable, it will just overwrite the data that is previously in that variable. Okay, so with floating point values, you need to put either a lowercase f or uppercase f at the end of the number. Otherwise, the compiler will just treat it as a double. It's just rules of the language. Alright, chillin'. So you know how to assign a variable, right? But what if you try to use a variable before it was assigned any values? This right here is bad, yo. This is called an uninitialized variable. The compiler, yeah, will give this variable a completely random value. And the thing is with this, yeah, every time you run your PC, the value that it has will be completely different. There's no way of predicting what values the compiler will give it. Okay, cool, so look, let's try and write out the contents of these variables without assigning them any values. So remember, we use two less than signs to denote that we want to output something else. We can put our variable names there, and the computer will try to output the contents of that variable. Alright, cool, so let's run this again and see what I want. Oh snap, there was an error thrown. It says we were trying to use an uninitialized variable. You see, this is dope. Visual Studio 2017's toolchain warns you about these things. Some other toolchains will not and will just run the program, so you gotta be careful. Okay, calm, so let's move this bit under where we've already assigned these variables some data. Highlight the code, press Alt and the up and down keys to move these sections of code. Alright, sweet, so let's run this. Alright, bless. So check out the data, right? Note that booleans will display 0 for false and 1 for true. It will not explicitly say true or false. You also may be wondering what's up with the character value. Well, I assigned it a new line character. There's some special characters that take a backslash first and then a letter. The backslash is called an escape sequence, and when you pair it with another letter, this will represent a special printable character. You see here, backslash n means new line. That's why there was a space between the character and the integer part. If I assign that variable with a basic character A, it will just print it like so. Alright, blessed. Well done for making it this far. I know this was kind of long, yeah, but the fundamentals are one of the most important things when you code. These things right here, you will 100% be using every single time that you code. There's literally no getting around it. So, now time for some drills. Alright, so drills. First drill for this episode. I want you to output a sentence that says, yo, what's good? I am insert age, years old, and my favorite letter is insert letter. Yeah, I know, kind of stupid, yeah. But the difference with this, yeah, I want you to put your age and the favorite letter as variables rather than just typing the data into the sentence. For the second assignment, I want you to experiment. Try to assign a character to an integer and output that variable and see what happens. Try to assign a floating point to a boolean, output it and see what happens. Just mix and match different values and variables. Have fun, keep pushing. See you in my next episode. Peace.
Be proud of who